When I look at this diagram, I'm focusing on trying to figure out what exactly I'm being asked to do. So I'm asked to find the measure of the angle CQG. And I need to make sure that when I'm looking at it, I can actually find it, because the other relationships I'm using all have information that will allow me to solve it. For example, I might look at this and think, oh, it's a 360. It is, but we don't have information about those angles, so trying to approach it as a 360 isn't going to help. What could help is recognizing that we have two vertical angles here, and that we have enough information about both sides of the vertical angles that we could write an equation. So the vertical angles, they're congruent to each other, and I noticed on one side I have 155 degrees, and on the other side I have that 3x. That was what I was hoping to be able to work with, and if I add the 56 to it, I have captured this relationship. So in fact, by looking at this as vertical angles, I'm able to write an algebraic equation that represents the geometric relationships I see in this problem. I can now solve this algebraically. I'll want to isolate the x term, so to do that, I will subtract the 56, the constant term, from each side of the equation. On the left, that leaves me with 3x, and on the right, it leaves me with 99. To solve this further, I will divide both sides by the coefficient of the variable, that's 3. And when I do that, I'm left with x with a coefficient of positive 1, which is what I was hoping for. And 99 divided by 3 is 33. So now that I know that x is equal to 33, I can go back to my original diagram, like the geometric piece, and I know that the measure of angle CQG was represented with the expression 3x. Well, now that I know what x is equal to, I can substitute that for x, at 33, and 3 times 33 is 99. So this allows me to say that the measure of angle CQG is 99 degrees.